Are atoms real? I I remember, and I'm going to preface this by saying, when I was growing up, everyone told me Pluto was a planet. Then all of a sudden, it wasn't a planet anymore. The Magic School
No.
Bus was like, "We're going to the planet Pluto," and now everyone's like, "Oh, Pluto's not a planet." Okay, sounds good. I can maybe see Pluto if I have a telescope. I can't see atoms. How do I know that atoms are real? Everyone tells me atoms are real. Nucleus of the atom, electron,
Hmm.
proton. Like your body is mostly empty space. How has anyone even actually seen these things?
You know, as you know, I always love to go back to first principles. And this is kind of one of those kind of a things, right? Because if you start to get down to it, right, it's like when people say first principles, quote unquote, one of them is like physical chemistry laws, right? Like you've got your periodic table, which is this collection of all of the atoms that we know about, which are these elemental things, right? And they have these structures with a certain neutrons and protons and then these electrons kind of flying around them in this like, you know, little mini solar system type thing. And I must admit, as a young man, I was also extremely dubious and extremely suspicious of uh, this presentation of everything is made up of these little things. And I often ask that question: How do we know? I have some answers actually because I do remember some of the chemistry that I took my freshman year because grades were important to me and I wanted to do well. So I actually
Well,
can tell you because
before
I
you throw
took.
out these answers, let me just say, like, biology makes similar claims about tiny things. They're like, "Oh, your body's made out of cells."
Sure.
There's paramecium in the water, but you know what? You can take a microscope and you can look at it. I
Yeah,
have
I've seen
vivid
it.
memories as a child of using a microscope to look at these things and saying, "Oh shit, that's
Yeah.
real."
Yeah.
Permanent change in my
Flagella?
mental model. I've never seen an atom, never seen one,
No.
so I'm skeptical.
I think you might be right. I think you're onto something there, actually. And I remember there was this one experiment that they claimed was kind of this idea of like, how do we know atoms are real? And I know, dude, we're probably like digging deep and somebody's proved something completely beyond this. If somebody knows better evidence of why atoms are real or not real, and it's actually a grand conspiracy, drop them in the comments, obviously. Reach out. We'd love to have you on. But there was this thing that they called the gold foil experiment. Do you remember this from chemistry? And it was basically, do you remember this one?
No, so actually, I never took chemistry. I took it sophomore year, but I had a very distracted teacher. He said that the first day of class, he was very depressed. He was like, "They're turning on CERN today, the particle collider, and we're all gonna die." And
Oh,
then,
he was one of these guys.
yeah. And then I didn't learn a single thing in chemistry. And actually, when I went to college, I took the chemistry placement test, and they're like, my counselor was like, "Don, you got fifth percentile on the chemistry placement test." I'm like, "Oh, top 5%. All right." And she's like, "Oh no."
No, no, no.
She was like, "You should
Other
never
five.
take chemistry at this university ever, no matter what someone tells you." And I was like, okay. I'm still thinking about how do percentiles work again? Yeah. So I know nothing about chemistry
Okay,
at
fair
all.
enough.
Yeah.
Well,
There
I
you go.
will.
Now
I
you
will
know.
give you. I will give you the high level thing, and due to the fact that the way that my brain works, actually, the name of the guy that did this just popped in my head because I believe his name was Rutherford, and I remember, I used to do all these like little memory tricks, and I remember, see, Rutherford was ruthless. Okay. And that's important to remember because of what I'm about to explain. So he had this like gold plate, film, like a foil of gold. And then because he was ruthless, he shot these like neutrons or some kind of particle at this gold foil. And he noticed that most of these particles passed right through the foil, like just went right through. Some of them were like reflected in like very odd orientations, like they had partially hit something, and very few of them were reflected directly back. And that was this idea that if they were deflected or reflected back, they were hitting the nucleus of these gold atoms. And if they passed right through, then they were just going right through. And because most of them passed right through, that implied that most of physical matter was actually open space. So I think that there's a lot of this like inference type evidence where it's like we're inferring that most of these things are empty space because we shot this particle and it just went right through the gold foil. It didn't hit anything. So it must be empty space.
Okay, hold up. Remember, I know nothing about chemistry. How did they know that these particles were doing anything? If the particles are as tiny as the atom, you can't see the particles. I don't know.
Yeah.
This all.
I think they got scanners or something, dude. Like, I don't know. Maybe they have a scanner somewhere. I don't know.
When did
These
this
are the kind
happen?
of
When did they do
details.
this test?
Oh, this was a long time ago. You can look it up, but like probably the late 1800s, early 1900s. I don't know. But I'm just saying that this is the way a lot of this science is done. And a lot of it is like, okay, but they didn't just take that piece of evidence in isolation, right? They used that in a whole spider web of other evidence to say like the best way that we know how to explain all of this evidence is this type of structure called an atom that has this nucleus and has these electrons around it. I think that's how a lot of this stuff happens.
Well, I think some evidence for atoms is that they figured out how to build an atomic bomb, right? I guess for me, the person who knows nothing about chemistry, I'm like, okay, well, at least they knew enough about this thing to figure out that if you could break this thing apart, you can make a huge explosion. So,
well,
that's impressive.
Well, that's where like these so-called like that's like one of the big things in science, right? Is can you explain the observations that you're seeing with some kind of model? It tends to be like a mathematical model of some type, right? Like, can you explain the predictions you're seeing with your model? And then can you actually make predictions about things that you have not seen yet and then verify those? And that's actually one of the famous stories around the development of atomic weaponry was there were a bunch of physicists who were like, these runaway chain reactions with things like uranium are possible. You just have to like kick them off. And then that runaway chain reaction is what we know as like a nuclear bomb, a nuclear explosion, right? And then now we have fission bombs or these, so what they call them, the hydrogen bombs, right? Which are a whole nother like thing. But it was like, literally there was this huge debate, I believe in like the 20s and the 30s amongst physicists of like, was that possible or not? And then this one guy, and I can't remember who it was, published a paper. And then finally Einstein was like, oh, like I do believe that this is physically possible. But it was all math. It wasn't like they had done anything. I mean, there had been like experiments and stuff to verify a lot of this, but like the first time they did it was the Trinity test, where they actually were like, okay, is this going to work? And the famous story is Einstein literally wrote a letter to FDR and was like, hey, just so you know, my professional opinion is now actually an atomic bomb is a real thing. It is possible. So you might want to look into this because if the Germans develop one, it is game over for you.
So I have a better question. Than are atoms real? Where is the boundary between observable and inferred physical reality, right? I can see a paramecium. I can see a cell with a microscope, right? When does that break down and when do they just start guessing about stuff? So you can see a lump of gold, but how do you know that a gold atom, how do you know it's not a gold molecule? How do you know... How do they know any of this stuff? I know nothing about this. I have no idea how they make that distinction in where observable reality breaks down and it's just inferred from math, like you said.
Well, I think that it is exactly what you just said. Observable reality is something that you actually can observe. Now, for you, the thing that you just talked about was visual observation with your own eye, right? But I'll give you an example of something that is not visibly observable, but is observable nonetheless, and you will guarantee it's true. If you take a big cast iron pot and you put it in the oven and you heat it to 500 degrees, and someone pulls that out of the oven and holds it in front of your face, you will feel the heat coming off of that thing hitting your face. That is an observation. But if you were to look at it visibly, it would look the same as a non-hot cast iron pan. So I think it's, if you step back abstractly a little bit, these are all just observations. Everything is observation. How do you know anything? Everything is being mediated through this observation lens. And then we build a state space model in our mind of what the reality actually is. But everything is perceived through our senses.
So I actually did some Wikipedia research. I read a Wikipedia article or two. And it has come to my attention that there are some holes in our understanding of physics, right? So they were able to make these. So there was this guess, right? Like, can we create a runaway nuclear reaction that results in a detonation? The Trinity test proved it correct. They're like, okay, we were right about XYZ things that we were only guessing about beforehand.
Sure.
Right now, I don't know a lot about quantum physics, but I understand that quantum theory, I understand this because I listened to like a 20-minute podcast and read a Wikipedia article, that the quantum theory explains electromagnetism, whatever, like the force between that holds an atom together. But gravitation is not explained by it. And gravitation is interesting. So more context. I have been attempting to give myself a scientific education that I never received. One of the ways that I've been doing that has been listening to the Feynman lectures on physics, some of which are on Spotify. They're really good. He sounds like Bernie Sanders because he's a Jewish dude from New York. But instead of being like the billionaires, he's like the strong and weak nuclear forces and the force of gravitation cannot be reconciled by current scientific understanding. That's
fascinating.
It's fun to listen to him. But the first lecture I listened to was on the theory of gravitation, and he says it's a theory because they had all these different ideas. He talks about the history of it, right? From like the invention of human, what's it called? Where you look at the stars and astronomy. And he's like, they started measuring the planets and they're like, okay, the planets move in these periods and in these spaces in the sky. And then no one put together people also knew that things would fall towards Earth, but no one put together that the speed of movement through the sky was the same as the speed of movement of stuff falling until Newton, I think. And that they needed to continually verify because they kept finding things in space that slightly violated their calculations, but that actually made them start to understand the gravitational forces between objects, right? How it's not just the sun, like they all exert forces on each other. I don't know. It was just like this process of continuous refinement. Anyways, that process is clearly not done because they have all these ideas of quantum physics that is largely downstream from math calculations they've made that just doesn't integrate with gravity at all. And so I'm not saying it's all fake, but where do we go from here? And what are normal people supposed to do about it?
I'll tell you what normal people are supposed to do about it, because actually I think you're 100% right. Whenever someone says something as stupid as the science is settled, immediately disregard everything else that they say. That's actually what you're supposed to do. So when someone gets up and goes, the science is settled on climate change, the science is settled on COVID, the science is settled on ... immediately disregard everything else they're saying because they're a political operative. And scientists would never say that. Ergo, exactly what you're talking about with these physics theories. Science is a methodology to learn more and disregard things that you've learned to no longer represent what you're actually doing. It's insane to me that they don't even teach this in schools anymore. They don't do that. They don't teach you how to think. They just tell you what to think now.
They
It's
just
a bunch
tell
of
you
idiots
Pluto's a
teaching
planet.
idiots.
And then they delete Pluto, like that guy in that photograph with Stalin that just got erased. That's like what happened to Pluto. They're just like, Pluto's not a planet. They don't even say anymore. They're just like, it's not.
Yeah.
But 5 years ago, what are you talking about?
Yeah, they just remove it. Well, and that's the whole idea, is that's actually a sign of progress. And what it's supposed to say is like, okay, we had this certain notion. We had reasons to call things. A little bit of that is just naming conventions. That's a little bit made up of what is a planet, what is not a planet. A lot of that stuff is just made up for convention's sake. And
are you saying Earth is a planetoid? Is that what you're trying to say?
I don't know. I mean, that's kind of what I mean. But when you kind of get beyond that, it's kind of like, well, what are we trying to do? We're trying to understand the worlds we live in, such that we can use that information to our advantage. So traditionally, a scientist was supposed to go out and learn information for information's sake. Why do things work the way they are? How do things work? What is actually out there? Are atoms real or are they not? And then they took that information and they typically handed it off to engineers, and engineers actually built things with that. Okay? The scientists build nothing. They don't build anything. If you're building something, that's an engineer. That's just semantically what an engineer is. I always got offended by that as an engineer. Scientists don't build anything. They just discover stuff and do cool things, discovering things, but they don't actually do anything with that knowledge. As soon as you start to do stuff with that, like take the Maxwell equations and build a radio tower, now you're an engineer. I just want to be very clear about that. Rant over. So to answer your question, Don, what do you do with it? You constantly are trying to expand your understanding and expand the predictive model's capabilities. You're trying to seek new knowledge. Now, you have to always be fighting against these institutions and people who have a vested interest in the current paradigm being continued, because they have no interest in completely undermining their careers.
I feel like hasn't it been like that for a long time? I mean,
it's been like
part
that
of my scientific education is involved reading about Copernicus and Galileo, and they were very what's the right word? Looked down on for their views. I mean, basically these pronunciations about reality at that point in time by the Catholic Church, who was kind of like the epistemic regime of Europe and kind of the authority on what was or was not real. Even something as simple as like the Earth revolves around the sun and not vice versa was damaging to their authority. And, I wonder if science is science. I guess by science, I mean like our model of extant knowledge of reality. It has always been a political tool, right? So like the times where you could actively question that and interrogate that are actually more of an exception than a rule. Like, why would you not want to control everyone's model of reality, right?
Well, I can give you a very good reason of why you wouldn't want to do that. Because I give you two ones. One is actually kind of more of just a purist reason of you actually want to know the truth yourself. And if you're only have yourself, we talk a lot about conspiracies on the program. We can't investigate every conspiracy. So the reason you wouldn't want to control someone else's perhaps worldview is because you actually want to know the truth. And why would you want to know the truth? Because it's in your own best interest to actually have people who are making decisions actually know the truth. So take, for example, COVID. I want to empower anyone who has a legitimate investigatory capability and prosecutorial capability to find out what actually happened with a lot of these decisions and prosecute people for very bad decisions that were made in nefarious reasons. Why? Because I don't want that to happen again. I don't even care about justice anymore in the past. I just don't want it to happen again. And we're not even close to that right now. That would be one example why, I think.
Yeah. Yeah, I wonder if the scientific, I guess this is just looping back to the universities as an idea, or just the universities period. Like the modern university system is a direct descendant of the medieval university system run
Yes.
by the Catholic Church, the same one that told Galileo to shut up.
Right.
To me, and correct me if I'm wrong here, the history of science from my smooth-brained Wikipedia education is something like you have these institutions that curate a body of knowledge and try to keep like a hegemonic control over what is considered reality. And then you have difficult people that make it impossible to deny their claims. You incorporate their claims, and then you try to reassert hegemonic control of reality. As far as I
Yeah.
know, has there ever been a free for all where people were truly all proactively engaged in seeking the truth? It seems like the people that really wanted to know what was actually true seem like outliers in every society, in every epistemic regime.
So I think that there's a couple different ways to take that. And I think that there is certainly some kind of a feedback mechanism on that. But I just want to take the side of the institution for a second and say, there actually is a responsibility of that. I can't remember the word that you used, but this idea of this chunk of knowledge that they're kind of guarding. What was the word you used? Because I liked it.
What, I think it was hegemonic reality.
Yes, exactly. Right. Like that idea, because if you actually are, let's take, for example, the National Institutes of Health, or, any of these kind of the CDC, any of these kind of groups, right? Like you actually do need to maintain an order, because for every Galileo that we remember in history, there were 100 people who were actually just crazy, saying all sorts of things. And so there needs to be coming to the defense of some of these institutions, because you can't just completely throw everything out every 6 months. If those of us working in AI know this now. We've basically been throwing out everything every 3 to 6 months over the last 3 years, and everyone's losing their minds. Because it's so easy to show, actually, this is just a better way of doing it. Actually, this is just a better way of doing this. Actually, this is just a better way of doing this. And you're like, yeah, and that's true. Oh, and that's true again. Oh, and that's true again. And it's just overwhelming. So it's like I'm not saying suppress the truth. That's not what these institutions were saying. But what they're saying is like, hang on. I'm not just going to believe you. You got to come up with a little more evidence, man. You got to come up with a little more evidence. And then at some point, there is this gradual turning where people say, actually, like, I think that guy might be right, man. Like, it looks a little more probable that that guy is right. That's when a paradigm shift happens.
I'm going to pivot the conversation because I have another question, and I'm learning a lot right now. Are they going to add more elements to the periodic table, or have they found all the elements?
Dude, no, there's definitely like undiscovered ones, but the whole idea of the periodic table, and again, I'm no chemistry expert, but like the whole idea is that gives you the framework of how the system works. So there are elements that have only existed for nanoseconds at a time on that table because they're like unstable. Like my favorite thing, being a Berkeley man, is they used to have this shirt. Berkeley is an absolute powerhouse in chemistry, absolute powerhouse. And so is Berkeley Lab up the hill, and a bunch of like the people out there in California, absolute powerhouse. And so there is actually a T-shirt that many people in Berkeley have that is Berkeley, the element berkelium, because it was invented, they kind of discovered it in Berkeley, and Californium, which is another element that they also discovered at Berkeley.
Nice.
So I just thought, I didn't have one, but I thought that was just the slickest T-shirt ever. Berkelium, Californium T-shirt.
It's a flex for sure.
It's very cool. There are many elements that have been discovered there. And it's that idea of like people kind of predict they're like, this is a missing spot. And so my understanding of chemistry basically in like the 18 and 1900s was just like filling in those things by doing these insane experiments with things like hadron colliders, this CERN and pressure cookers and all sorts of crazy stuff to try to get the reaction, the conditions such that that element could exist. But because they're so unstable, they fall apart.
I'm learning so much right now. I've already learned more than my entire high school chemistry class. So you just cut me off when I've asked too many questions because this
dude,
could
I don't
go
even.
on for a long time.
I hope I'm correct on this stuff. I hope the audience fills it in. That stuff, I'm like pretty sure on all that stuff. Yeah.
Okay. Next question. Do you think that some of the implications of quantum theory could create a materialist explanation for things that have been considered parapsychology? I know that you've read a lot of Carl Jung. I read some of it as well. There's a lot of stuff tangential to that. Carl Jung is a medical professional ultimately, and medical professionals need to be very in touch with ground truth reality because of the survivability of their patients, right? And just the nature of medical education. Yes. So I took his claims of parapsychological phenomena kind of seriously. And this is maybe an example of you talk to enough people who say that they've had a dream of someone dying and then they find out they died and they weren't in the same place. That it's almost the same as like these people in the 1920s and 30s being like, so we looked at all these equations and we feel like an atomic bomb could maybe work. It's like, I've talked to all these people and I think maybe remote viewing and astral projection could work, right? And then do you think some of these quantum theories and elements of what they've come to understand there could create materialist explanations for some of these phenomena?
Yeah, so to answer your question, I'll just give you the answer. I think, of course, it's possible. I do not believe that to be the case. As a theist, I don't believe that to be the case, but possibly. And I want to step back and answer your question by this, right? There's all these different like frameworks and models to try to explain these things. So for example, a very common one is like stochastics and probability versus like a deterministic physics-based model. So for example, Newtonian physics there's no probability in that. It's just deterministic equations. And they give you remarkably good predictions of what actually happens in like kind of mechanics, let's say, bouncing a basketball, shooting a rifle, that kind of stuff. Really, really good. There's no statistics needed. Then there's other types of phenomena that like we're just not that we don't have as good a models, I guess you would say. And so they'll enter in these like statistical models where they're like, well, I take a bunch of averages and then I model this whole population, for example, everybody's height, as this like random variable. I'm not actually building a computer model of every single person on Earth and then trying to do like they have kids and they have kids and building this thing. It's like I don't have a model to predict that, but I can measure everybody's behavior and then put it on like a bell curve and start to talk about like distributions and probability. These are like fundamentally different approaches to investigate a lot of these things. Now you've got these crazy guys like Terence Tao, brilliant mathematician guy who's like, I see the connection between algebra and probability. And he's got this very soft-spoken voice, and like only he and like 3 or 4 other guys. It's like Good Will Hunting level math, where like no one sees it but him. And then they spend the next 6 months writing papers and explaining it, and then it takes the rest of us 10 years to understand it. Most of us never get there, but like you see what I'm saying. So there's like all of those like unifying theories of math and everything. So the reason I bring those up is because that's the way I think about a lot of these like quantum things, where you're like, hey, like it's pretty clear the models that we have right now don't explain everything. They do some stuff really, really well, but they don't explain everything. So obviously we're missing something. Now, if you were to ask me and many of the theists out there, they'd say like, well, it's actually more probable that like God created the world, and these things, and it's like more reasonable and fits the data better and is less of a stretch to say that there is a God and that explains a lot of these things. Now they'll say that that's, a cop out and this, that, and the other. Maybe. But at the same time, you'd say, okay, well, hey, maybe, I don't know. You're putting just as much faith that there is a alternative theory that you just haven't discovered yet. And you're kind of relying on actually a very similar logical path. You just don't think that way because you don't have a God with a capital G in it, but you've got some other model in there. You understand what I'm saying? So there's a lot of different approaches to these things that people would say, but I think it's totally possible. Yeah.
Yeah. I don't want the audience to, I could keep asking questions, but I know for the audience sake, we have to wind it down at some point, but just circling back to the are atoms real? You can't see them, and you have to infer their presence. Like, how much of reality is just stuff that you have to infer? Like, for me at least, and I know this is funny because a viewer who gave me a little feedback said that our segments always collapse into epistemics. No matter what the topic is. How do we know she's a spy?
Exactly. That's all that matters, though.
It's how much of the world, because you can only ever personally experience such a narrow slice of reality, how much of this stuff do you actually have to just infer, right? Like, we live in these huge complex systems. I just infer that the economy is the way that it is based off things I like watch on CNBC Squawk Box and read on FinTwit. So that could be accurate or inaccurate. I have no idea, right? Like, how much of reality? I feel like we just have to infer most of reality, and that's the state of the human condition in the 21st century, which is not an easy spot to be in. It would have been a lot easier to live, as we said last episode, in a hunter-gatherer community where, oh my God, this is a whole, I'm not even going to go down that rabbit hole. I started reading on Wikipedia about haplogroups and how the San Bushmen are actually, like, they proved recently via DNA that, like, they are the original humans. And then, like, there was a divergence. All other humans have DNA from, like, this other haplogroup, and the divergence, it's like the San Bushmen and everyone else, which is kind of crazy. But anyways, that's a total. Yeah, I don't know. Some things you can figure out. Some things you just have to infer. I don't know. It can be exhausting for people that want to know the truth.
Well, that was supposed to be the job of your family and of your culture and your society, was supposed to be part of that. And part of that was supposed to be like, if I'm raised right in my family, I just get a lot of this by osmosis. Why don't I do X? Well, because my family told me to, and this, that, and the other, and I'm just inferring this. I don't have to go like reinvestigate, name something, a gambling addiction. Like, that's just part of my society's rules and baked in. So I don't even have to like go explore that. I can just take that for granted. Why is getting married helpful? I don't have to go back and do this whole first principles things. It's just like I'm living through culture and society, and I'm kind of just inferring a lot of these things. And a lot of these things are actually like the wisdom of generations passed down. Like, there's many people who are, I think, idiots and very foolish when they say, like, what do I have to learn from some religious text, say it's the Bible, the Quran, whatever, like from these people 10,000 years ago? Like, what does it even matter? And it's like, well, if these texts lasted that long, there's something in them that's worth learning about, because people preserved them. Why would they preserve them if they weren't worthy of something? Even if it's the negative, right? Like, don't do that,
Well, and if a lot of reality is inferential instead of explicitly provable,
exactly.
You have people who've been doing that since the beginning of history, and probably even longer. And their inferences, especially the ones that have lasted and propagated, may be kind of accurate.
Yeah. Well, I got to say, Don, we were all over the place on this one. I think this might be a good place to wrap. if that's okay with you.
I endorse that. Yep.
All right.
Atoms are not real, and I'm just kidding.
They might
and
not
that's
be.
it.
But dude, jokes aside, my final comment, maybe there actually is a better explanatory model than that fits the data even better, but we just don't see it yet. And I pray that kid that comes and finds that model, whether it's a guy, a gal, American, Chinese, I just hope that they have the courage to stand up and make their voice heard and present that. And then eventually people will have enough humility to accept that model if it works better.
Right on, Brederick.